Draw the image of shape A after a translation by the vector 8, -6. This simply means that we need to move each point on triangle A 8 units to the right and 6 units downwards. After doing this, we are able to map out the translated image of triangle A. Draw the image of shape A after a reflection in the line y is equal to -1. So first, we need to draw the line y is equal to -1. For point A, since we move 6 units downwards to touch the line of reflection, we also need to move 6 units downwards to pin the new position of point A. For point B, since we move 3 units downwards to touch the line of reflection, we also need to move 3 units downwards, pin the new position of B. For point C as well, since we move 3 units downwards to touch the line of reflection, we also need to move 3 units downward from the line of reflection to pin the new position of point C. After doing this, we are able to map out the reflected image of shape A. Describe fully the single transformation that maps shape A onto shape B. When we look at shape A and shape B, we can tell straight away that this is an enlargement by a scale factor of 3. The next thing is to find the center of enlargement. We can do this by connecting at least 2 corresponding points on both triangles A and B. The intersection point of these lines is the center of enlargement. When we do this, we get -5, 5 as the center of enlargement. And so the full description will be enlargement by a scale factor of 3 about the center -5, 5. Describe fully the single transformation that maps shape A onto shape C. When we look at shape A and shape C, we can tell straight away that this is a rotation 90 degrees clockwise. The next thing is to find the center of rotation. To do this, we first need to connect at least 2 corresponding points on shape A and shape C. When we are done, we draw the perpendicular bisectors of these lines. The intersection point of these bisectors is the center of rotation, and in this case, we get 1, 1. And so the full description is going to be rotation 90 degrees clockwise about the point 1, 1. A plane has 14 first-class seats, 70 premium seats, and 168 economy seats. Find the ratio first-class seats is to premium seats is to economy seats. Give your answer in its simplest form. So for the ratio, we have 14 is to 70 is to 168. The common factor here is 14, and so this helps us simplify the ratio into 1 is to 5 is to 12. For a morning flight, the costs of tickets are in the ratio first class is to premium is to economy is equal to 14 is to 6 is to 5. The cost of a premium ticket is $114. Calculate the cost of a first class ticket and the cost of an economy ticket. So let's set up our ratio. And in this ratio, we are going to represent the cost of a first class ticket with X and the cost of an economy ticket with Y. To find X, we are going to set up our equation from these two. This gives us X is equal to 14 over 6 times $114, giving us $266. To find Y, we are going to set up our equation between these two. And this gives us Y is equal to 5 over 6 times $114. This gives us $95. For an afternoon flight, the cost of a premium ticket is reduced from $114 to $96.90. Calculate the percentage reduction in the cost of a ticket. To find the percentage reduction, that is equal to the reduction, which is $114 minus $96.90 divided by the original cost, which is $114 times 100%. When we type this into the calculator, we get 15%. When the local time in Athens is 9 o'clock, the local time in Berlin is 8 o'clock. A plane leaves Athens at 13:15. It arrives in Berlin at 15:05 local time. Find the flight time from Athens to Berlin. So we know that the plane leaves Athens at 13:15 and it arrives in Berlin at 15:05. To be able to find an accurate flight time duration, we need to convert 15:05, which is the local time in Berlin, to the local time in Athens. And this gives us 16:05 because the local time in Athens is 1 hour ahead of the local time in Berlin. When we subtract 13:15 from 16:05, we have a flight time duration of 2 hours 50 minutes. The distance the plane flies from Athens to Berlin is 1,802 kilometers. Calculate the average speed of the plane. Give your answer in kilometers per hour. Speed is equal to distance traveled divided by the time taken. We have the distance traveled as 1802 kilometers, and for the time duration we have 25 over 60 hours. This gives us 636 kilometers per hour. The box and whisker plots show the times spent exercising in 1 week by a group of women and a group of men. Below are 2 statements comparing these times. For each one, write down whether you agree or disagree, giving a reason for your answer. For the first statement, we have, on average, the women spent less time exercising than the men. I disagree with this statement because the median time for the women is greater than the median time for the men. For the second statement, we have the times for the women show less variation than the times for the men. I also disagree with this statement because the women have a higher interquartile range than the men. The frequency table shows the times T minutes each of 100 children spent exercising in 1 week. Calculate an estimate of the mean time. The mean is equal to sigma f of x divided by sigma f. In this case, sigma f of x represents the total number of minutes all the 100 children spent exercising in 1 week, and sigma f represents the total number of children. To find sigma f of x, we first need to find a value for the average time. And so for the first time interval, the average time will be 0 plus 60 divided by 2, which is 30. 60 plus 100 divided by 2, which is 80. 100 plus 160 divided by 2, which is 130. 160 plus 220 divided by 2, which is 190. 220 plus 320 divided by 2, which is 270. Sigma f of x is going to be 41 times 30 plus 24 times 80 plus 23 times 130 plus 8 times 190 plus 4 times 270 divided by sigma f, which is 100. When we type this into the calculator, we get the mean as 87.4. The information in the frequency table is shown in this cumulative frequency diagram. Use the cumulative frequency diagram to find an estimate of the 60th percentile. 60% of 100 is 60. When we map this on the diagram, we get the 60th percentile as 90 minutes. Find an estimate of the number of children who spent more than 3 hours exercising. 3 hours is equal to 3 times 60 minutes, which is 180 minutes. When we map 180 minutes on the diagram, we have 92. And so the number of children who spent more than 3 hours exercising is equal to 100 minus 92, giving us 8. A histogram is drawn to show the information in the frequency table. The height of the bar for the interval t is greater than 60 and less than and equal to 100 is 10.8 centimeters. Calculate the height of the bar for the interval t is greater than 160 and less than and equal to 220. So first, let's look at the interval t is greater than 60 and less than and equal to 100. The height of this interval is the frequency density, and so when we apply the frequency density formula, we know that the frequency of this interval is 24 divided by the interval width, which is 100 minus 60. This gives us 0.6. However, in this case, the height has been given as 10.8 centimeters, and so this means that 0.6 has been multiplied by a scale factor to get 10.8, and this scale factor is 18. So for the second range, the frequency density will be equal to 8 divided by the interval width, which is 220 minus 160. This gives us 2 over 15. To get the actual height of this interval on the histogram, we multiply 2 over 15 by the scale factor, which is 18, and that gives us 2.4 centimeters. A rectangle measures 8.5 centimeters by 10.7 centimeters, both correct to one decimal place. Calculate the upper bound of the perimeter of the rectangle. To get the upper bound of the perimeter of the rectangle, we need to first find the upper bound for the length and the width. Since we are correcting the length and width to one decimal place, we bring plus and minus 0.1 and divide it by 2. To get the upper bound of the length, we ignore the minus. This leaves us with 10.7 plus 0.05, which is equal to 10.75 centimeters. For the upper bound of the width, we have 8.5 plus 0.05, which is equal to 8.55 centimeters. So now, the upper bound of the perimeter of the rectangle is 2 times the upper bound of the length, which is 10.75, plus 2 times the upper bound of the width, which is 8.55 centimeters. This gives us 38.6 centimeters. ABDF is a parallelogram and BCDE is a straight line. AF is 12 centimeters, AB is 9 centimeters, angle CFD is 40 degrees and angle FDE is 80 degrees. Calculate the height h of the parallelogram. To find the height of the parallelogram, we can apply SOHCAHTOA. This gives us sine 80 degrees equals h divided by df, which is 9 centimeters. When we make h the subject, we have 9 times sine 80 degrees centimeters. When we type this into the calculator, we have h is equal to 8.86 centimeters, correct to 3 significant figures. Explain why triangle CDF is isosceles. Angles on a straight line add up to 180 degrees, and so when we subtract 80 degrees from 180 degrees, we get angle CDF as 100 degrees. The angles in triangle CDF must add up to 180 degrees. So when we subtract the sum of 100 degrees and 40 degrees from 180 degrees, we get angle DCF as 40 degrees. Since there are 2 equal angles in triangle CDF, it is an isosceles triangle. Calculate the area of the trapezium ABCF. To find the area of the trapezium, we have half of BC plus AF times the height. We know the height is 8.86 centimeters, and we've also been given AF as 12 centimeters. BC is equal to BD minus CD. BD is 12 centimeters. Since triangle CDF is an isosceles triangle, the lengths of CD and DF are equal, and so CD is 9 centimeters. We have 12 minus 9 centimeters giving us 3 centimeters. When we slot in all these values into our equation, we get the area of the trapezium as 66.5 centimeters squared. A, B, C, and D are points on the circle center O. Angle ABD is 21 degrees and CD is equal to 12 centimeters. Calculate the area of the circle. We know the formula for finding the area of a circle, which is pi r squared or pi d squared over 4, where d is the diameter of the circle. In this case, the diameter is AC, and so we have pi times AC squared divided by 4. When we look at the diagram, we can say that angle ABD and angle ACD are equal because angles in the same segment are equal. The other point is that an angle subtended at the circumference of a circle by a diameter is 90 degrees. And so triangle ACD is a right-angled triangle. So to find the length of AC, we can apply SOHCAHTOA. This gives us cosine of 21 degrees is equal to 12 centimeters divided by AC. When we make AC the subject, we have 12 over cosine of 21 degrees centimeters. When we put the value of AC into our original formula, we have pi over 4 times 12 over cosine of 21 degrees squared. This gives us the area of the circle as 130 centimeters squared, correct to 3 significant figures. The diagram shows a square with side length 8 centimeters and a sector of a circle with radius 9.5 centimeters and sector angle x degrees. The perimeter of the square is equal to the perimeter of the sector. Calculate the value of x. We've been told that the perimeter of the sector is equal to the perimeter of the square. The perimeter of the sector is equal to 2 times 9.5 centimeters plus the arc, which is x over 360 degrees times 2 pi times 9.5, and the perimeter of the square is 4 times 8. When we simplify this, 2 times 9.5 gives us 19 and 4 times 8 gives us 32. When we move 19 to the other side of the equation, we have 32 minus 19 giving us 13. When we make x the subject, we have 13 times 360 divided by 19 pi. When we type this into the calculator, we have 78.4 degrees, correct to 1 decimal place. The diagram shows the graph of y is equal to f of x for x is greater than and equal to -3 and less than and equal to 3. Solve f of x is equal to 14. To do this, we draw the line y is equal to 14 on the grid and note the x coordinate of the intersection point. This gives us x is equal to 2.75. By drawing a suitable tangent, find an estimate of the gradient of the graph at the point -2,4. So first, we draw our tangent at the point -2,4. In addition to the point -2,4, let's find another point on our tangent. We are going to use these 2 points to estimate the gradient. And so we have m is equal to -4 minus 4 divided by -3 minus -2. When we type this into the calculator, we get 8. By drawing a suitable straight line on the grid, solve f of x is equal to 2x minus 2 for x is greater than and equal to -3 and less than and equal to 3. So first, we are going to draw the line y is equal to 2x minus 2 on the grid. To solve for f of x is equal to 2x minus 2, we are going to note the x coordinate of the intersection point between the graph f of x and the line y is equal to 2x minus 2. When we do this, we get x is equal to -2.85. The diagram shows a curve with the equation y is equal to 2x squared minus 2x minus 7. The straight line with equation y is equal to 3x plus 5 intersects the curve at the points A and B. Find the coordinate of points A and B. To find these points of intersection, we are going to solve the equation of the curve and the equation of the line simultaneously. When we put equation 1 in equation 2, we have 2x squared minus 2x minus 7 is equal to 3x plus 5. When we move all the terms to one side of the equation and group like terms, we have 2x squared minus 5x minus 12 equals 0. We have a quadratic equation, and so to find the value of x, we are going to apply the quadratic formula. This gives us negative 5 plus and minus square root of negative 5 squared minus 4 times 2 times negative 12 divided by 2 times 2. The values under the square root simplifies to give us 121. For the first value of x, we have 5 plus square root of 121 divided by 4, and this gives us 4. For the second value of x, we have 5 minus square root of 121 divided by 4. This gives us negative 1.5. Since A is on the positive side of the x-axis, it means that the x-coordinate of A is 4. And since point B is on the negative x-axis, the x-coordinate of point B is negative 1.5. To find the corresponding y-coordinates of these 2 points, we can substitute these values of x into either equation 1 or equation 2. In this case, I'm picking equation 2. And so for point A, when x is equal to 4, y is equal to 3 times 4 plus 5, giving us 17. Hence, the coordinates of A are 4, 17. For point B, when x is equal to negative 1.5, y is equal to 3 times negative 1.5 plus 5. When we type this into the calculator, this gives us y is equal to 0.5. Hence, the coordinates of B are negative 1.5, 0.5. The diagram shows a field ABCD on horizontal ground. BC is 192 meters, CD is 287.9 meters, BD is 168 meters, and AD is 205.8 meters. Calculate angle CBD and show that it rounds to 106.0 degrees, correct to one decimal place. To find angle CBD, we can apply the cosine rule. And so when we apply the cosine rule and make angle CBD the subject, we have cosine inverse of CD squared minus the sum of CB squared and BD squared divided by negative 2 times CB times BD. When we slot in the values of CD, CB, and BD given in the question, we get angle CBD is equal to 106.015 degrees. 0 is the first number after the decimal point. The number after 0 is less than 5, and so we maintain 0 and ignore the rest of the numbers. This leaves us with angle CBD equals 106.0 degrees, correct to one decimal place. The bearing of D from B is 38 degrees. Find the bearing of C from B. On the diagram, the bearing of C from B has been indicated with an orange arrow. This angle is equal to 38 degrees plus the angle from this point to this point. This angle can be found by subtracting angle CBD, which is 106 degrees from 360 degrees. This gives us the bearing as 292 degrees. A is due east of B. Calculate the bearing of D from A. On the diagram, the bearing of D from A has been indicated using the purple arrow. We've been told that A is due east of B. This means that these angles are each equal to 90 degrees. When we subtract 38 degrees from 90 degrees, we get angle ABD as 52 degrees. If we subtract 90 degrees from 360 degrees, we get 270 degrees, which is the angle from this point to this point. The angle from this point to this point is angle BAD, and we can find it using the sine rule. This gives us sine BAD divided by 168 is equal to sine 52 degrees divided by 205.8. When we make angle BAD the subject, we get 40.0 degrees, correct to 1 decimal place. Hence, the bearing of D from A is 270 degrees plus 40 degrees, which is equal to 310 degrees. Calculate the area of triangle BCD. When we apply the formula for the area of a triangle, which is half AB sine theta, we have half of 192 times 168 times sine of 106 degrees meters squared. When we type this into the calculator, we get 15,500 meters squared, correct to 3 significant figures. Thomas buys the triangular part of the field BCD. The cost is $35,750 per hectare. Calculate the amount he pays. Give your answer correct to the nearest $100. Note that 1 hectare is equal to 10,000 meters squared. So first, let's set up our ratio to convert 15,500 meters squared into hectares. When we do this, we get 1.55 hectares. So if 1 hectare is equal to $35,750, then 1.55 hectares will be at a value which we are going to represent as X. And so from our conversion ratio, we have X is equal to $35,750 divided by 1 hectare times 1.55 hectares. This gives us $55,400. These are the first 4 diagrams of a sequence. The diagrams are made from white dots and black dots. Complete the table for diagram 5 and diagram 6. For the number of white dots, 1 squared gives us 1, 2 squared gives us 4, 3 squared gives us 9, 4 squared gives us 16. And so for diagram 5, we have 5 squared equals 25. And for diagram 6, we have 6 squared equals 36. For the number of black dots, the terms are increasing by +1, +2, +3. And so to get the number of black dots for diagram 5, we have 6 plus 4 giving us 10. And for diagram 6, we have 10 plus 5 giving us 15. The total number of dots in diagram 5 is 25 plus 10, giving us 35. And the total number of dots for diagram 6 is 36 plus 15, giving us 51. Write an expression in terms of n for the number of white dots in diagram n. And so that is n squared. The expression for the total number of dots in diagram n is 1/3 times 3n squared minus n. Find the total number of dots in diagram 8. So all we need to do is substitute n equals 8 into the equation. And so we have 1/2 times 3 times 8 squared minus 8. This gives us 92. Find an expression for the number of black dots in diagram n. Give your answer in its simplest form. The number of black dots is equal to the total number of dots minus the number of white dots. We know that the total number of dots is half of 3n squared minus n, and we found the number of white dots as n squared. When we expand the brackets, half times 3n squared is 3/2n squared. Half times negative n is negative half n. 3/2n squared minus n squared is half n squared. And so for our final answer, we have half n squared minus half n. T is the total number of dots used to make all of the first n diagrams. T is equal to an cubed plus bn squared. Find the value of A and the value of B. You must show all your working. To find the value of A and the value of B, we are going to pick and use 2 sets of data from the table. When n is equal to 1, the total number of dots is equal to 1. When n is equal to 2, that is for the first two diagrams, the total number of dots is 1 plus 5, which is 6. When we substitute n equals 1, t equals 1 into the equation, we have a times 1 cubed plus b times 1 squared equals 1. This simplifies to give us a plus b equals 1. When we substitute n is equal to 2, t is equal to 6 into the equation, we have a times 2 cubed plus b times 2 squared is equal to 6. When we simplify this, we get 8a plus 4b is equal to 6. We now have two equations in terms of a and b. We need to solve these two equations simultaneously. Let's use the elimination method. When we multiply equation 1 by 4, we have 4 times a, which is 4a, 4 times b is 4b, and 4 times 1 is 4. Let's label this equation 3. So now when we subtract equation 3 from equation 2, we have 8a minus 4a, 4b minus 4b, which is 0. And so it cancels out, and we have 6 minus 4. 8a minus 4a is 4a, and 6 minus 4 is 2. When we make a the subject, we get 2 over 4, which simplifies to 1 over 2. So now that we have the value of a, we can substitute that in either equation 1 or equation 2. When we substitute it in equation 1, we have half plus b is equal to 1. When we make b the subject, we have 1 minus half, which is half. For our final answer, we have a is equal to half, b is equal to half. Factorize completely. 3a squared b minus ab squared. When we factor out ab, we are left with 3a minus b. This cannot be factorized further. Solve the inequality. 3x plus 12 is less than 5x minus 3. When we group like terms, we have 12 plus 3 is less than 5x minus 3x. 12 plus 3 is 15. 5x minus 3x is 2x. When we divide through the inequality by 2, we have 15 over 2 is less than x. 15 over 2 in decimal is 7.5. So we have 7.5 is less than x, or this can be rewritten as x is greater than 7.5. Simplify. 3x squared y raised to the power 4 cubed. This becomes 3 raised to the power 3, x raised to the power 2 times 3, and y raised to the power 4 times 3. 3 raised to the power 3 is 27. For the powers of x, we have 2 times 3, which is 6. And for the powers of y, we have 4 times 3, which is 12. So our final answer becomes 27x raised to the power 6, y raised to the power 12. Solve 2 over x is equal to 6 over 2 minus x. When we cross multiply, we have 2 times 2 minus x is equal to 6x. When we expand the brackets, 2 times 2 is 4, 2 times negative x is negative 2x. When we group like terms, we have 6x plus 2x, which is 8x, is equal to 4. When we make x the subject, we get x equals 4 over 8, which simplifies to 1 over 2. Expand and simplify. X minus 2 times x plus 5 times 2x minus 1. When we expand the first two brackets, we have x squared plus 3x minus 10. And when we expand the resulting two brackets, we have 2x cubed plus 6x squared minus 20x minus x squared minus 3x plus 10. 6x squared minus x squared gives us 5x squared, and negative 20x minus 3x gives us negative 23x. So our final answer becomes 2x cubed plus 5x squared minus 23x plus 10. Alan invests $200 at a rate of R% per year compound interest. After 2 years, the value of his investment is $206.46. Show that R squared plus 200R minus 323 is equal to 0. In this case, we can apply the compound interest formula, where big A represents the value of his investment after 2 years, and this has been given as $206.46. Small a represents the initial amount he invested, and that has been given as $200. R is the rate, which has been given as R%, and T is the time duration in years for which his money was invested, and that is equal to 2. When we expand the brackets, 1 squared gives us 1. 1 times R over 100 is R over 100. We multiply this by 2 and it gives us 2R over 100. R over 100 all squared gives us R squared divided by 10,000. 200 times 1 is 200. 200 times 2R over 100 is 4R. 200 times R squared over 10,000 is R squared over 50. When we multiply through the equation by 50, we have 50 times 206.46 giving us 10,323. 50 times 200 is 10,000. 4R times 50 is 200R. And R squared over 50 times 50 gives us R squared. When we move all the terms to one side of the equation, we have R squared plus 200R plus 10,323 minus 10,000, which gives us minus 323 equals 0. Solve the equation R squared plus 200R minus 323 equals 0 to find the rate of interest. Show all your working and give your answer correct to 2 decimal places. When we apply the quadratic formula, we have R is equal to negative 200 plus and minus square root of 200 squared minus 4 times 1 times negative 323 divided by 2 times 1. The terms under the square root gives us 41,292. For the first value of R, we have 1.60, correct to 2 decimal places. The second possible value of R gives us negative 201.60, correct to 2 decimal places. The value of R cannot be negative in this case, and so we have R is equal to 1.60, correct to 2 decimal places. There are 32 students in a class. 5 do not study any languages. 15 study German. 18 study Spanish. Complete the Venn diagram to show this information. 5 do not study any languages, and so they will be placed in this part of the Venn diagram outside set G and set S. So now that we have taken these 5 students out, we are left with 32 minus 5 students, which is 27 students. To find the number of students who study both German and Spanish, we subtract 27 from the sum of 15 and 18. This gives us 6. So now the number of students who study German only will be 15 minus 6, which is 9. And the number of students who study Spanish only will be 18 minus 6, which is 12. A student is chosen at random. Find the probability that the student studies Spanish but not German. This probability is equal to the number of students who study Spanish and not German, which is 12, divided by the total number of students, which is 32. 12 over 32 can be simplified further to give us 3 over 8. A student who studies German is chosen at random. Find the probability that this student also studies Spanish. This probability is equal to the number of students who study German and Spanish, which is 6, divided by the total number of students who study German, and that is 15. 6 over 15 can further be simplified to give us 3 over 5. A bag contains 54 red marbles and some blue marbles. 36% of the marbles in the bag are red. Find the number of blue marbles in the bag. So first, we know that 36% of all the marbles in the bag are red, and the number of red marbles are 54. And so when we make the total marbles the subject of our equation, we have 54 times 100 divided by 36. This gives us 150. This means that the number of blue marbles is equal to 150 minus 54. This gives us 96. Another bag contains 15 red beads and 10 yellow beads. Ariana picks a bead at random, records its color, and replaces it in the bag. She then picks another bead at random. Find the probability that she picks 2 red beads. For this probability, we have the probability that her first pick is a red bead and her second pick is also a red bead. The probability that the first bead she picks is red is equal to the total number of red beads, which is 15, divided by the total number of beads, which is 15 plus 10, and 15 plus 10 is 25. After picking her first bead, she replaces it in the bag, and so the probability that she's going to pick a red bead again is equal to 15 over 25. 15 over 25 times 15 over 25 gives us 9 over 25. Find the probability that she does not pick 2 red beads. The probability that she picks 2 red beads plus the probability that she does not pick 2 red beads must be equal to 1. And so the probability that she does not pick 2 red beads is equal to 1 minus 9 over 25. This gives us 16 over 25. A box contains 15 red pencils, 8 yellow pencils, and 2 green pencils. 2 pencils are picked at random without replacement. Find the probability that at least 1 pencil is red. We have 3 different scenarios. In the first scenario, a red and yellow pencil are picked. In the second scenario, a red pencil and a green pencil are picked. In the third scenario, 2 red pencils are picked. The probability that the first pencil picked is red is 15 over 25. Without replacement, the probability that the second pencil picked is yellow is 8 over 24. Without replacement, the probability that the second pencil picked is green is 2 over 24. Without replacement, the probability that the second pencil picked is red is 14 over 24. For this scenario, a red pencil can be picked first and a yellow pencil picked second, or a yellow pencil picked first and a red pencil picked second. And so we are going to multiply this probability by 2. For this probability as well, a red pencil can be picked first and a green pencil picked second, or a green pencil picked first and a red pencil picked second. And so we are going to also multiply this probability by 2. When we type this into the calculator, we get the final probability as 17 over 20, or 0.85. The diagram shows a sketch of the curve y is equal to x squared plus 3x minus 4. Find the coordinates of the points A, B, and C. The y coordinates of points A and B are 0. And so when we substitute y is equal to 0 into the equation of the curve, we have x squared plus 3x minus 4 is equal to 0. This quadratic equation can be solved by factorization. We replace 3x with negative x plus 4x. For the first 2 terms, when we factor out x, we are left with x minus 1. For the final 2 terms, when we factor out 4, we are left with x minus 1. This can be rewritten as x plus 4 times x minus 1 is equal to 0. For x plus 4 equals 0, we have x equals negative 4. And for x minus 1 is equal to 0, we have x equals 1. A is on the negative side of the x-axis, and so the x-coordinate of A is negative 4 and the y-coordinate is 0. B is on the positive side of the x-axis, and so its x-coordinate is 1 and the y-coordinate is 0. At point C, the x-coordinate is 0. When we substitute x is equal to 0 into the equation of the curve, we have y is equal to 0 squared plus 3 times 0 minus 4. This gives us y is equal to negative 4. And so for the coordinates of C, we have 0, negative 4. Differentiate x squared plus 3x minus 4. For x squared, 2 times the coefficient of x squared, which is 1, gives us 2. When we subtract 1 from the power, we have 1. This gives us 2x. When we differentiate 3x, we have 3. And when we differentiate any constants, in this case negative 4, we have 0. And so our final answer is 2x plus 3. Find the equation of the tangent to the curve at the point 2, 6. The tangent is a straight line, and the equation of any straight line can be written in the form y is equal to mx plus c. All we need to do now is to find the values of m and c and put them into this equation. Since the tangent touches the curve at the point 2, 6, m is equal to dy dx at x is equal to 2. We've already found dy dx as 2x plus 3, and so we have 2 times 2 plus 3 giving us 7. To find the value of c, we need to substitute the coordinates given in the question, and so this gives us 6 is equal to 7 times 2 plus c. When we make c the subject, we have -8. Hence, the equation of the tangent is y is equal to 7x minus 8. On the diagram, sketch the graph of y is equal to tan x for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. The graph of y is equal to tan x has been sketched on the diagram. Solve the equation 5 tan x is equal to -7 for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. When we make tan x the subject, we have -7 divided by 5. So first, we find the value of alpha, which is tan inverse the positive value of tan x, which is 7 over 5. This gives us 54.5 degrees, correct to 1 decimal place. To get the full range of values for x, let's draw our quadrants. The value of tan x is negative, and so we are going to draw our line in these quadrants where the value of tan is negative. The value of alpha is from the horizontal line to the line we've drawn. And so when we go around the quadrant the first time, we have the first value of x as 180 degrees minus 54.5 degrees. This gives us 125.5 degrees. When we go around the quadrant the second time, we have the second value of x as 360 degrees minus 54.5 degrees, and this is 305.5 degrees. So for our final values of x, we have x is equal to 125.5 degrees or x is equal to 305.5 degrees. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.